And now we need to do the augmentation. So what shall we do?
Define L.
On L. L simply I,
I.
you know what? N equal to size. If you say size of A, let's see what that will return. It returns number of rows, number of columns. Adam? Number of rows, number of columns. Since we know that, for example, in this case, I don't have B. That's all. I don't have the B vector. I only need to do the factorization. Right? So in order to do the factorization without having the B vector, I can say size 1. What does that mean? N equal size of A 1. What does that mean? Take the first dimension, which is number of rows. And if I say 2, what does that mean? Takes the second index, the number of columns. It does not matter in this case. Rows and columns are the same. لأنها square matrix. طيب. That is N. Next, what shall I do?
L is equal to
L
IN.
equal to I N, right? Where N is a 3 by 3. Where, okay, that is done. Next, what shall I do? Define the, or let's say initialize the U matrix. Initially, what was U? The أول خطوة.
U is equal to A.
U is equal to A, exactly. Okay. Now U is equal to A. تمام. All right. Factorization. So now I want to make sure that that element becomes 0. Okay. So how can I handle that? Let's calculate L 2, 1, isn't it? That element, how much is it? It equals U 2, 1 divided by the pivot 1, right? Which is minus 1 over 4. Done with that. Okay. Now that element has been updated. Next, what shall I do? Row number 2 is equal to 0, isn't it? We should make sure that the second row starts with 0. Okay. So row 2 equals the old row minus the L2, 1, which is basically that 1 over 4 or that minus 1 over 4 times the pivot row. Minus the pivot row اللي هو السطر الأول. Okay, that is done. It is 0 now. By the way, guys, should we continue to the next line? Should I go and do that step now? Is it necessary?
No, doctor.
No, I don't need to do it. And even if you did it, يعني إذا رحت وقلت U3 equal to the U3 minus blah blah blah, still nothing will change. L will be 0 and U will be 0 because it's already 0 there. Okay? طيب. Can I automate the process? Sort of. Can I kind of automate this process? I will define R equal to now 3 because I'm going to the third line. K equal to the second pivot, right? And let me just go ahead and copy this stuff. Let me copy this stuff over there, and I will replace it by I and K. Replace it by I and K. Right, and that will be replaced by K comma K, right? So if I execute now this line, what do you think? What will happen in this matrix? Which element is going to change?
Will be third row, second column.
Okay, so basically that element, right? That element. Okay, that element will be updated. Come on. Okay, let's do that. Let's do that. Now, yeah, it has been updated. Perfect. So in the same line, by the way, in the same line, I can continue. Okay, I can continue saying now the new I row equals the old ith row minus lambda في السابق نسميها lambda. This time it is L I comma K multiplied by the pivot row. Which pivot row are we talking about? دائما K comma K. Okay, so it multiplied by U, open a bracket, that is K. Okay, so if I execute that line, now notice that element has been updated into 0. That's it. This is what I want. I now have a upper triangular matrix. Look at it. I do have an upper triangular matrix now. It's not working. Just a minute. I do have an upper triangular matrix. Okay, it's not working anyhow. You get the point. You get the point. Okay, next step is to and I do have the L matrix as well, right? So let's just look at L. This is the L matrix, where we have a lower triangular matrix. Okay, this is the lower triangular matrix, and that is the upper triangular matrix. Okay, for completeness, L times U should equal
A.
And to make sure that this is the case, just subtract them, and you will notice that we have zeros, which means yeah, it equals A. Come on.
دكتور
نعم.
انت فوق دكتور كتبت سطر حطيت فيه كم من عملية ال واليو حسبتهم كلهم في سطر واحد إذا ما فصلتهم بسيمي كولون عادي
لا إذا ما خليت السيمي كولون then there is a problem. MATLAB says if I execute this line, it says invalid expression. So in order to show both processes, يعني حساب ال, the calculation of L and the calculation of U, you can put a comma over there. So if you do that, then it works. Then you will see both L and you will see both U. Okay?
Okay.
Okay. That is done. By the way, Shabab, I asked you, I think, in the last lecture to write a code that automate this process, isn't it? And I said post it in your OneNote. Correct?
حطيت في الهومورك دكتور.
تمام.
Yes.
That is done. طيب شباب, let's move to a new topic now. Chelosky. Okay. So let me just move it aside. Now, guys, we have seen.
دكتور قبل لا نبدي
نعم.
الاساينمنت هذا هو اللي نسوي في جروبات ولا كل
Yes,
واحد
the assignment which has been sent on Teams. This is the one which you will do it into any groups. Okay.
زين دكتور كل واحد يطرش الاساينمنت
لا
ولا
only one member of the groups of each group will upload the work. So basically, this is the cover page, the assignment title, names, and IDs, for example, something like that. Okay.
اوكي دكتور.
Okay. So guys, now we move to the third method, which is Cholesky's decomposition. And this method, rather than separating the A matrix previously in the LU decomposition, we separated A, or we decomposed A into L and U, lower triangular matrix versus upper triangular matrix, correct? Zeros over there. Right, this time we will decompose A into lower triangular matrix, 1 zeros over there, multiplied by the same matrix, but this time it's transposed. It is transposed. So basically, okay, so basically, we will find only one matrix rather than finding both L and U. It is the same matrix. One time it will be multiplied in its lower form, and the other time it will be multiplied by its upper form, the transposed form of it. Okay, is that clear? So for Cholesky to work, in order to apply this method, matrix A must meet two requirements. First of all, matrix A must be symmetric, okay? Symmetric, and second condition, it should be positive definite. Okay, positive definite. What do I mean by that? Let's tackle the symmetry first. When can I say that matrix A is symmetric? Look at the following matrix. Look at the following matrix. طيب شباب, I have A, B, C. I have B, D, and E. I have C, E, and F. I want you to look at the following. Guys, can you see that A, B, and C is identical to A, B, and C? Yeah?
Yes دكتور.
Yes, doctor.
Yes.
All right. The next row, can you see B, D, and E is identical to B, D, and E? And finally, then you see that C, E, and F matches C, E, and F. If that was the case, what do we say? We say that the matrix is symmetric. A is symmetric, right? So how can you check symmetry now in an easy way? I want to check whether matrix A is symmetric. Simply, matrix A should equal its transpose. Then notice the row is transposed into a column. The second row is transposed into the second column. The third row was transposed into the third column. So if matrix A equals its transpose, then we say that matrix A is symmetric. How can you do that easily? let's say in MATLAB. How would you do that operation?
We can say A minus A transpose, and if we get 0, that means it's
Exactly, zeros, right? Zeros, right? If you get a matrix of zeros, then we say that the matrix is symmetric. Come on, that was the first condition. Right, the second condition is positive definite. When can we say that the matrix is positive definite? Well, let me just write it. Matrix is positive definite if all eigen values are positive. Okay, for those who are taking linear algebra right now, they can relate to the meaning of eigenvalues. Basically, an eigenvalue is a certain number that corresponds to the matrix, and it describes some physical quantity or mathematical quantity. And eigenvalues emerge in different fields. In dynamics, it emerges in quantum physics, and quantum mechanics. What else? Yeah, this is what I remember right now. Okay, so making it short, this is a value which is related to the matrix, and it describes some physical, let's say physical or theoretical quantity. Right. How can we check now if all the eigenvalues are positive? How can we check if the matrix that we have is positive definite, i.e., how can we check that all the items are, all the eigenvalues are positive? In order to do that, let's take matrix A. Right? And let's check its first element. In this case, it is only one single value, right? One by one, right? It's a scalar quantity. We need to find the determinant for, if you remember, this was the symbol for determinant, صح? بالشكل كان. We need to find that the determinant for the one by one, and it must be positive. Okay. Then we move to the second square part, which is 2 by 2. So I can 1 by 1. It was a scalar quantity. Now it's 2 by 2. What shall we check? Again, check if the determinant of this part, the 2 by 2, again positive. All right. Then we should continue as well. Let's move to.
Doctor, I have a question.
Yes.
When we get the eigenvalues of 2 by 2, do we also count? Do we also count 1 by 1?
Yeah, you will count it. Exactly. You'll count the previous part. You're dealing with a square matrix, right? Which basically covers all the previous ones. Right? Again, that 3 by 3, the determinant must be positive until you hit the last one, which is the determinant of, let me change the color again, until we hit the determinant of matrix A. Again, it should be positive. What do we conclude? We conclude that
Matrix is positive definite.
Exactly. All right. Matrix A is positive definite. Okay. That is done. طيب شباب, if matrix A fails in one of these conditions, let's say whether it was symmetry or it was positive definite test, we need to do 2 tests, right? In order to check that whether matrix A can or whether Shedowski's method is applicable If it fails one of them, what we conclude?
We can't apply the method.
Exactly. Cholesky's method is not applicable. It is not applicable. Right. This is wrong. It should be something like this. Okay. L times L transpose is equal to A. Right. This is L transpose, which is basically lower triangular matrix 0 and 0. And that is L21, L22, and 0, L31, L32, L33, multiplied by the transpose of that. Take the first row, make it a column, L11, 0, and 0, right? Take the second one, L21, revise second row, make it a column, L22, and 0. And finally, the third row, make it the third column, L31, L32, L33. All right, next. I assume now everybody knows how to multiply two matrices. Adel? Okay, what is the first element now? I need to find the first element. What should that be?
L11 times L11.
L11 squared, correct? All right. Now let's find the second element over there. It is again the first row multiplied by the second column. So that is L11, L21, right? And then 0 times cancels out. All right. Let's move on. Okay. Then what do we have in the next? It is L11 times L31. Correct?
Yes. And
okay.
The rest is 0. So
then what do we have? Let's move
row 2, column 1.
Let's move to the second column now. Let's move to the second column. Let's move to the second column. That is second column, second row, first column. That is L21, L11. Can you see that? By the way, guys, notice since matrix is symmetric, هذا المفروض يكون نفس دي. عدل? Because the first row equals the first column. Matrix is symmetric. This is one of the conditions that this matrix has. Okay. Now let's move to the second row, second column. So that is L21 squared plus L22 squared, isn't it? All right.
Yes.
And the third one, L21 times L31 plus L22, L32. Okay, that's it. I assume you can continue. You can continue the last row because I will do it later on. This is the answer. This is the answer. I'm saying the following. Can this symbolic process be done in MATLAB? And the answer is yes. The answer is yes. Let's see how can we reproduce this matrix symbolically in MATLAB. This is kind of extra thing that I'm showing you because you might see it handy, especially if you are deriving some complicated algebraic expressions for this course or for any other courses. Okay, so let's switch.
يعني دكتور بنخليه يكتبها بالرموز.
Yeah, yeah.
Okay.
Okay, so in the command window, for example, let me define the following. Sims, what does that mean? Create a symbolic variable. That symbolic variable, how many elements do I have? I have the following. I have L11, L21, L31. You know what? I will just go and copy this stuff. L11, L21, L3, L22, L31, L32, L33 as well. Okay, 6 elements. So, okay, those are some. Now let me define matrix L. Matrix L is L11, 0 and 0. Second row, L21, L22, and 0, right? L31, L32, L33. That is matrix L. Okay. Now take matrix L, multiply it by its transpose. المفروض نحصل ايه مرة ثانية. Okay. You will notice that we ended up with the same L11, L11. Well, I will note it, L11 squared, right? But we had it with the conjugate. Why that is the case? Because when we defined L11 as symbolic variable, it might be real number or it might be an imaginary number. Adel? For the transpose of a real number will not change anything, but the transpose of an imaginary number will lead to changing the angle. This is shall I يشتغل الحين? No. It's not working. I can't write on the screen. Okay, let me move back to OneNote. So, 3 plus something 2i. Okay. When you find the conjugate, what will happen? Or sorry, when you transpose this matrix, what will happen? So this I to this number, the imaginary number, this stays the same, but this element will change its sign, right? So because MATLAB assumes that those L's can be real or imaginary, it said, you know what? It's the conjugate of that. So in case we are dealing only with the real number, what can we do? Go over there and say all these numbers are real. All these numbers are real. And let us do the multiplication one more time. And as you can see, it is L11 squared, L11, L2, 21, and so on. Exactly as we have done by hand. Okay? Okay, so next, what do we have? I'm just putting that code for completeness. Okay, let's now, guys, investigate two things. Let us investigate the diagonal elements. Let's just for a minute or two. I want you to look at the diagonal elements. What can you see, guys? شنو قاعد يصير فيهم؟
The half square.
Okay, first of all, we can see that each element of the diagonal is squared, right? Okay, this is a squared, that is a squared, 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 squared. Okay, Shabab, can we find a general rule for that? Can we find a general rule for that? What's happening? Can you see that for row 1, it is L11. Okay, for row 2, 1 squared. Row 2, L21 plus L22 squared. For 3, L31 squared plus L32 squared plus L33. Can you see that you always start with the row number? Let's say row I, 1 squared plus I2 squared plus I3 squared until you hit I squared. Can you see that this is what's happening? Is
Yes,
that okay? So in that case, let's just let me write it down. So for diagonal elements, we had A11 equals L11 squared, correct? Okay, and A22 equal مثل ما قلنا 21 squared plus 22 squared, right? A33 equal to L31 squared plus L32 squared plus L33 squared. طيب شباب, let's check. A55, how many elements it would have?
5.
5, okay. 5, that's correct. 5, let me write that down. So what are those 5? 5, 1,
L51 plus
Yeah.
L52 square.
Okay, 5, 3 squared plus L54 squared plus L55 squared. Perfect. Okay. Now, so generally speaking, now let's generalize it. AII equals LI1 squared plus LI2 squared plus ماشي إلى LI squared, right? Okay.
Yes,
This is the general rule. طيب. Now, let's go back and let us check the off-diagonal elements. Let us check the off-diagonal elements. Okay. So this is one of the off-diagonal elements. A21 says does not matter, but let me look at the following. A12. Oh yeah, A21 is 1121. Come on. 33 is 1131. So what is happening here? What can we say? Again, I'm looking at a pattern right now. I want to kind of find a formula for that. So what is happening? Can you see that 2, 1, row and column? Okay. So it's like saying اكتبها L1 من الثاني L2 In other words, I want to say we have the rows and we have the columns. Okay. Maybe that is not clear. Let's look at this. So A32. Okay. A32. First of all, for the 2, 1 and the 3, 1, we can see that it has only one element. Yani you are not summing you are not summing 2 elements. But when it has A32, you have 2 elements and the in that location. So for example, A32, we say something plus something, right? 2, because it has 2 elements. Like what do we have? L, and L, right? If I say 3 for the rows and 2 for the columns, since I'm doing that twice, 1 and 1. 1 and 1. Again, 3 for the rows and 2 for the columns, and we'll 2 and 2. By the way, this is identical, now. Okay. So, for example, if I say A 4 and 2, how many summations are we doing first of all?
2.
2. تمام. And of course, it's L, 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 and L. All right. What shall I do? Order for the rows, 2 for the columns, 4 for the rows, 2 for the columns. This is 1, 1, correct? And that is 2, 2. Can you see it? What if I have A 4, 3? How many summations should I have?
3.
3. Okay. Again L, again L. All right. So 4, 3. What else? Sorry. 4 and 3. 4 and 3. 4 and 3. 1, 1, 2, 2, 3, 3. Can you see that, guys? Is that clear?
Yes, sir.
Okay, so for the off-diagonal elements, guys, for the off-diagonal elements, I can say the following. For matrix A, for element I, j, it equals, notice LL plus LL, I said I and J, I and J. This is for row, this is for column, row, column. Okay. What else? 1, 1, 2, 2, 3, 3 until you hit the JJ, correct? صح؟ we're going to 1, 1,
Yes, correct.
2, 3, 3 until you hit J and J, correct? Then you stop. So how can I express that mathematically? I will say the following. I will say I'll put a free index, they call it free index, K and K, correct? K and K, and I will do the summation. I will do the summation since this is a summation for K equal to 1, okay, all the way to J. IK JK الK مرة رقم 1 ثاني 2 ثاني 3 4 5 ليه؟ We hit J and J. Is that clear?
فكل مرة تزيد 1.
كل مرة تزيد 1, yes. Okay, so that is the off-diagonal elements. Off-diagonal elements. I'm saying I is larger than J. I is larger than J. Okay. That's all. We have done that now. We have done that now, and I'm just writing the, okay. Yeah. That's all. Let's say now we need to find the factorization. We need to find the factorization of matrix A. So as we have seen, matrix A equals L times L transpose, and we know how to write L, we know how to write L transpose, we know how to multiply them. So we can say the following. L11 squared, element, equals A11. This means L11 equals square root of A11. Done? Shall we move to the next element? 1, 2. By the way, 1, 2, and 2, 1 are the same, right?
Yes, doctor.
طيب A21 equals L11 L21. طيب L11 times L21 equals to A21, right? So in this equation, A11 is known. We just found it. So this means L21 equals A21 divided by L11. Okay, now L21 is known. Let us move to the next element. L31 of L11. L31 equals A31. Notice again L11 is known. L31 equals A31 divided by L11. Okay, we found it now. We found the following now. Those three elements, which means we found those three elements as well. Then هذا لين نفس لين. All right. Okay. Let's move to the next one, A22. So guys, A22, let me write it in this way. L21 squared plus L22 squared equals A22. Right? Those are identical, those are equal. So what shall I do now? And notice that L21 is known. We just found it over there. So this is known. So L22 squared, how much is it? Minus L21 squared. And in order to find L22, it's everything under the square root. Is that clear? Are we done with that element?
Yes.
Okay, so next, let us move to L32 now. L32. So guys, L21, L31 plus L22, L32 equals A32. Guys, L21, is it known? Let's look at
yes.
known. L31, is it known?
Yes.
Yes. L22,
Also known.
we just found it. This is the only unknown. L32 equals A32 minus L21, L31, correct? Divided by L22. Like, let's find the last one and then we'll break. We'll have we'll do it after the break. عشر دقائق شباب نرجع مرة ثانية. Okay. في 10 minutes and we'll start the second part of the lecture. يلا.